Okay, so welcome to this new lecture on problem solving in database management systems. Today we will be actually solving some questions on relational algebra, relational calculus. Most of the questions are on relational algebra because that's a very, very important topic. Relational calculus, what I could see was only one question given in the last 6 years. So relational calculus is something that is not the focus of this lecture. It's still recommended for you to study that. You never know. And if you kind of believe in bad luck, then certainly you should, because if you leave, it might be the case that they ask it in your gate only. So, but still, they have not been asking since long. So, main thing is to work on the concepts. And once you know about relational algebra, that is also enough to know about relational calculus. Once we do questions on today, tomorrow we will be actually looking at SQL. SQL, as you know, is one of the languages used to query the database. That's why it's called structured query language. So expectation is please be prepared with SQL for tomorrow. There are a lot of tricky questions that are asked in both today's lecture and the next lecture actually. But only way to be good in these lectures in this concept is to solve more and more questions. So I will tell you in this lecture how to solve questions, and unlike any other lecture, in this lecture I will actually give you some time to solve each question, because the idea should be that you should actually think, use your pen and paper. Um, if you don't have your pen and paper now, please bring it up, because that's required for this lecture. You need to do a lot of rough work. Try to solve them on your own. Think through each of the question, and then we will discuss. Okay, that's the idea that I'm trying to follow for today's lecture and even tomorrow's lecture. Okay, so let's begin then with a quick review on what things are in relational algebra. So relational algebra has a few important concepts. In a sense, what it has is 1 second. Slide takes a time to load. Yeah, basically this is everything about relational algebra. Um, Again, these all are drawn by me to only give you a quick refresher, cheat sheet kind of thing, so that you can refer to it one day before the exam as a revision. These were actually from directly my notes. I had handwritten notes. I just made them as a slide. So when I was a student, I used to maintain them like this. So relational algebra operators are basically divided among two. One is called basic operators and another is called extended operators. Basic operators are further divided into something called unary operation and binary operators. One is called the unary operators, one is called the projection operator, selection operator, and rename operator. Anyone, what does the projection operator do? Anyone who wants to answer? You may be wrong, okay? Don't worry, but try to answer. See, if you guys don't answer, I will pinpoint people, and that's what I don't want to do. Okay, so I will pinpoint people and ask questions then, if that's the case. Because let's be serious now. It's 2 months only, right? What is the projection operation? Have you guys studied this to concept? First of all, let's ask that. So, what is the projection operation? What does it do? For example, let's say if I have a table like this, ID and name, and it has some set of ID, some set of names, right? I will, let's say, write this. And let's say the name of this table is R. So pi ID R. What does it do? So what does this thing do? It selects the column ID, or it selects the attribute ID. Whatever attributes I specify here, it will select that, right? It will select the column ID. And what is pi? Pi is the projection operator. So this is what is projection. Again, let's go step by step each of the operators. Again, there are quick notes that I have written for each of the object operator for you. Uh, so you can refer to this as well. It takes some time to load. 1 second. Yeah. So one is the selection operator, right? Selection operator is denoted by this sigma, and there is a selection condition, right, on a relation R. Now you may use logical operators like and, or, not, and relational operators like equal to, not equal to, greater than, less than equal to, greater than equal to in the selection condition. Selection operator always selects the entire tuple. It cannot select a section or part of a tuple. And the number of rows that are returned by a selection operation is obviously less than or equal to the number of rows in the original table. So what does it mean is, let's say if I give you a problem, let's say this is the ID, this is the name, and this is the salary. Okay, let's say there are 3 columns in a table, ID, name, and salary. I'll just write some random numbers 1, 2, 3, 4, 5. Okay, and let's say name also I write in name also I give some names. So A, B, C, D, E, right? Let's say I have salary 1 lakh, 2 lakh, 1.2 lakh, 1.5 lakh, 2 lakhs. Okay, just some random salary that I have written. If I ask you a question, can you tell me in relational algebra, not in SQL, in relational algebra, how can I retrieve all rows which have salary 2 lakhs? What will you do? Can you return me all the tuples, all the rows which have salary 2 lakhs? Sigma salary 2 lakh R. Very good, very good. So sigma salary 2 lakhs of R. So this is very simple. Let's say this is the relation R. Sorry, I did not give the name, but you guys maybe assume that the relation name is R, which is okay. So the R, the selection condition, selection operator is the sigma. You specify a selection condition. The selection condition is salary should be 2 lakhs on the relation R. And if you write this operator, the result will be, you will get this tuple and this tuple. Okay, tuple with ID 2, tuple with ID 5. What is a tuple? Tuple is nothing but a row. It's a row. Okay, now let's add a few more columns to it. Let's say I add one more column to it. I name it age. Okay, let's say age is 23, 25, 21, 27, 26. Okay, let's say I also tell you, not just give me the salary 2 lakhs. Can you tell me the salary, sorry, can you return the tuples which have more than 23 age, who have an age greater than 23? Return me the tuples. I need the information where the age is greater than 23. Not greater than equal to, greater than 23. So you will again write sigma, then age is greater than 23 of R. Right? Perfect. Very good. Yeah. Perfect. So this will return you the tuples which have an age greater than 23. Let's say I want to club these two things and say that the 1 second, let me try to make some corrections. Let's say I make this 24, right? 21 is an age where normally people don't start working, but I made it 24. Okay. Now I want you to again select those people who have age greater than 23 Also, their salary should be more than or equal to 1.5 lakhs. How will you write the relational sigma operation? Age should be more than 23 and salary should be more than or equal to 1.5 lakhs. Very good. There are two ways to do this. One is what Jigya wrote in the chat, very good, which is sigma age greater than 23. And how do you write and? And is this cap, right? And salary is greater than or equal to 1.5 lakh of R. Okay. If you were actually doing SQL here, you would write select star from R, where age is greater than 23 and salary is greater than or equal to 1.5 lakhs. So relational algebra is a bit the beginner of some more mathematical way of writing things compared to SQL, which is more programmatic way of writing things. So this is what is relational algebra. And also, sorry, this is what is selection operator. So you will also have to keep in mind that the minimum cardinality and maximum cardinality, if you also give the other exams apart from GATE, one of their favorite questions are this only, like how many minimum number of elements can you get? Zero, right? And so can anyone give me an example query, any example query given this table where you will get 0 rows? Any example query, anyone? Where you will get 0 rows? Sigma salary greater than 2 lakh. In this table, as you can see, there is no person with salary greater than 2 lakh. So you will get how much? You will get 0 rows, and cardinality is the number of rows. So just for your notes, I'm writing it here for you to refer later. Sigma salary greater than 2 lakh of R. Okay. And the maximum cardinality that you can get is the number of rows present in the original relation R. Can you give me an example of a query where you will get the maximum cardinality? Yes, any example query where you get the maximum cardinality? You may negate the above one, right? Which is salary greater than 2 lakh. Salary is less than or equal to 2 lakh. You'll get all the rows that are there in the table. So sigma salary less than or equal to 2 lakh of R. Okay. Yeah, salary greater than or equal to 1 lakh is also one good example that you have. You may fill your notes accordingly, whichever you feel best. Okay. This is for your notes. Okay. This is for your notes only, not mine. So feel free to edit it accordingly. Okay. So now the next operator that we look at is something called projection operator. Projection operator works like this. You specify pi projection p pi, right? So you specify a list of attributes that you want to retrieve from the relation R. What are the attributes? Attributes are nothing but the columns that are present in the relation. So in this example, let's say you want to retrieve the same example I have earlier. You have ID, you have name, you have salary, and you have age. Let's say I ask you, can you give me can you return the name and salary attributes? What will you give what is the query for that? To retrieve the name and salary. Pi of name and salary. So there is pi name, comma, salary of R. Okay. Okay. Now let's spice things up. look into this relation R now. I am interested to know all the people who have salary more than 1.5 lakhs, and I do not need anything except the name. I just want the name of people who have a salary of more than 1.5 lakhs. What will you write? Understood the question? I need the name of people who have a salary more than or equal to 1.5 lakhs. I only need the name. I am not concerned with anything. I don't need the ID. I don't need the age. What shall I write here? Very good. So first, what I will do is I will select the people who have a salary of more than 1.5 lakhs. So how will I do that? I will write sigma salary more than or equal to 1.5 lakhs from the relation R. Okay. This will give me all the employees who have salary more than 1.5 lakhs. And the relation that I got, I will apply the projection operation such that I only get the name from it. Is this clear, everyone? Others? Seems like I'm only teaching Vishnu and Jigya. Others? Shruti, yes, okay. Okay, okay, perfect, perfect. So this is what it is, right? You can combine these two operations, and there is a comment written at the last, that is the commute. Very good question. Actually, very, very good question. Vishnu is asking, can we interchange sigma and pi? Does anyone want to answer Vishnu first? Let's see if someone knows this answer. If not, then I will answer. Anyone who wants to answer Vishnu's question? Can we interchange sigma and pi is the question. So you mean to say, can I do this? I write pi. I write pi of name sigma salary greater than or equal to 1.5 lakhs of R. Is this the same as writing sigma of salary greater than or equal to 1.5 lakhs? Pi of name R. Is this the question you are asking? Okay. Do you want to think an answer first, or should I tell you the answer, Vishnu? Try to think once. Try to see if I apply this operation. After this, my relation contains what columns? Let's say the relation is R prime. If you apply the projection operation on relation R, the new relation, let's say it's called R prime. What are the columns that are present in R prime, Vishnu? Okay. Is the salary present there? Will the salary be present? Okay. Now, do you want to answer, or should I tell you the answer now? You are applying the selection operation on a column which does not exist. In the earlier case, does the column exist? In the earlier case, your selection operation gave you all the columns and you are selecting the pi. But is this always true? What if I want to do this? What if I want to do this? How can I change the projection operation if I want to do this? What is missing in the projection operation? You are just getting the name. What else do you want such that you can apply the sigma? The salary. So if I write here name comma salary, now is this correct? Still no. Read the third point in projection operation. Does projection operation keeps the duplicates or removes the duplicates? If you have two people having, let's say, both having name A, both having a salary of 1.2 lakhs, the projection operation will remove them, will consider only one with A 2 lakhs. But the selection operation, if you apply first, it will return you these two columns. But okay, when you apply the projection operation, you only get A. So I think these are the same. But is the concept clear? If you interchange, what can be the implication? Because see, what I'm trying to say is if you apply the projection after getting these two rows, you will anyway remove the duplicate and get capital A. It's a very good question. I was actually, I think when I was learning this concept, the instructor, which was on YouTube, told me that also explained this part. So yeah, it's not always the case that it will be interchangeable. Okay. Now now let's focus back on the last point. That can I erase this, Vishnu? So what I wanted to say was, look at the earlier point. I asked you a question that the age should be more than 23, as well as that the salary should be more than 1.5 lakhs. So the other way to write this would have been this. So sigma of age more than 23 of the relation R. Okay. And then I put another selection operation. I put another selection operation and I say select person with salary more than or equal to 2 lakhs. It was 1.5 lakhs. I just wrote 2 lakhs. Okay, don't mind. So this is the same as writing sigma of age greater than 23 and salary is greater than or equal to 2 lakhs. And if I interchange these two selection conditions, will there be any effect? No, there won't be any effect. Now the question is, let's say I get some set of attributes from pi. Let's say I call it A1, some set of attributes, okay? And from the relation capital R. And let's say after that, I apply another projection operation and A2. Now, if I interchange A1 and A2, will there be any issue? Will there be any problem if I interchange A1 and A2? If yes, can you give me an example from the relation capital R? If yes. Let's say A1 is ID comma name, okay? And A2 is name. Can you see any problem if I interchange the two projections? What will happen if I interchange the two projections? Yes, what will happen if I interchange the two projections? ID column will not be displayed. See, the first one you will get ID comma name from A1, right? And then you are getting the name from that. If you interchange, you first get only the name and then you are expecting to get the ID as well. So ID column will not be displayed. Very good, Vishnu. Right? Very good. So ID column will not be displayed. In essence, the problem is commutativity will not be followed. Okay, it's in precision operation. Again, these questions are not important for GATE. GATE may there are much difficult questions asked. These are important for theoretical exams like ISRO, not exactly theoretical, but one who doesn't go into much concept, like ISRO, BITS, IIIT Hyderabad, and all that, and also good for clearing concepts, which are, but gateway, there are much more difficult questions asked compared to what you see here. So now this is another operator that is very common, very famously used, called the rename operator. Okay, and what it means is you can actually rename the attributes of a relation using this operator. So just to give you an example, let's say I have the same data. Okay, I have the same data. I want to get the, okay, this is the problem. I want to get the name and age of all employees with salary above 1 lakh. Okay, all till here you have already learned how to do the resultant relation. The resultant relation, which is the relation that you get after this, the resultant relation should have the columns named as should have the columns named as name 1 and age 1. Okay, understood the problem? Now, can you first try to solve till the point that you actually get the tuples of name and age of employees whose salary is above 1 lakh? Yes? How will you do that? You already learned that, right? Few minutes back. Yes, anyone wants to answer? Yes. So, oh, you also, no, not quite. Wait. Right, perfect. Okay, okay, good, good. Yeah. So what you are saying is you will get the sigma salary is more than 1 lakh from the relation R. This will give you all the tuples. Now, once you get all the tuples, you want only the name and age, right? Now, along with this, what I will do is I will apply the rename operator called row, and I will say name 1, age 1. Okay. Now what it does is it will first, so selection operation everyone knows, it selects all employees with salary more than 1 lakh. Then you project the name and age columns, so you get pi of name and age. And then the resultant relation that you get with the columns as name and age, you rename them to name 1 and age 1. Okay. Are the basic operators clear, everyone? Yes. Okay. Okay. So these are also called unary basic operators. Now let's move to the binary basic operators, starting from okay. Okay. What I will do is I will speed up a bit because we are yet to start solving questions. And okay. So I'll just explain you what are the binary operators. They are very simple if you know the unary operators. Okay. Now union, right? Union is a very simple operation. So if you have a set of tuples and so if you have a relation R1 and another relation R2, okay, if you apply the union, you're basically what you're trying to do is the rows that are present in R2, you're adding them to R1. So R1 has a set of rows. If you do R1 union R2, R2 will append those rows, add those rows one by one to R1. Okay. So what could be one of the conditions if you want to do union? Can you always do union? Let's say R1 has 5 attributes, R2 has 6 attributes. Can you do union? You should have same number of columns. Very good, Vishnu. That's the whole point. You should have same number of columns, and also you should have the same data type of the columns. If one, so same data type as in, if the first column has a data type of string, second, and the for R1, for R2, if it is an integer, sorry, you can't do union because that's not allowed, right? So you need to make sure that they have the same data type as well as the same number of columns. Same data type may not be very true for relational algebra, but I'm just also telling you in the terms of SQL. Now, this is also something called cross product. Cross product is very simple, right? Cross product I will discuss for some time, so hold on to that. Set difference is pretty easy to look at. It's nothing but R1 minus R2. So you retrieve all the tuples in R1 that are not present in R2. It's like set difference, so I'm not going inside all of that. So now there are some extended operators as well. One is called the join operator, and why they are called extended operators is you can write these operators in terms of the basic operators. You can use the basic operators to write the extended operators, right? That's why they are called extended operators. You can derive them in terms of basic operators. One is join, one is division, and one is intersection. We have questions in that are present in the exam that we will use to explain these operators. Okay, I don't want to explain and then go to the questions. What we'll do is for the extended operators, there are a lot of questions, right? We will do one thing, we will go to the questions straight away and then talk about them. I will only talk about cross product for now because that is a very important operation. So, and also I didn't find a question on cross product, so I thought that is important to talk about. So the cross product operator, right? So cross product operator, one second. Right. So cross product operator, I just had an example, one second. Okay. Yeah. So let's say there is a table R1, okay, and it's divided into some fact that it has a registration number. Let's call it 1, 2, 3. Okay. There is a branch, let's say CS, EC, and civil engineering. And let's say the person's name is A, B, C. Okay. This is one relation. Let's say the other relation R2 has just the name and the registration number. Okay. So there is registration, or let's not call it name, let's call it uh, okay, let's call it name only. Fine. Sorry. Okay. Here the name is CD and the registration numbers are 4, 5. Okay. Okay, first of all, can you union these two columns? First question. Can you union these two rows, these two relations? Is R1 union R2 permitted? That's my question. No, right? You cannot do R1 union R2. He didn't teach you actually union because it's very simple, but just asking questions, if you answer, that means you understood it. So R1 union R2 is, you don't need to do that because they do not have the same number of columns. Okay. So can you do R1 intersection R2? Still no, right? You cannot do R1 intersection R2. Let's say if I tell you this, can you answer what is the output of this? Pi of R1. Let's say I get the name and I want to intersect with pi of R2 given the name. What is the answer? What is the answer? C. Right? Very good. C. It returns C. Now, if I do pi of name from R1 union pi of name from R2, what do I get? What do I get? Will I get this? Will I get this or something else? Why is this output incorrect that I wrote? So this one, so if you guys all are saying ABCD is the answer, I think ABCCD was the answer. Why am I wrong? What did I do mistake? See, I have done a mistake. Okay, I just want you to be confident in answering that you are correct. Okay, yeah, duplicates are not allowed, sir. So I wrote a duplicate thinking that it's allowed, but it's not allowed. So I will only get C. Good. Okay. Now, what will be the answer of this pi of name of R1 minus pi of name of R2? What are the rows returned if you write this? AP, right? And is it commutative? Like, is pi of name R2 minus pi of name R1 the same as this? Is it commutative? No, right? If you do that way around, you will get the answer as D, right? You won't get AB, you will get D. Okay, very good. And the other two are commutative, if you see, right? Other two are commutative. Okay, so this was, I just wanted to discuss this also. So it's good that we discussed it. Okay. So now cross product. Okay. So this R1 has three tuples and R2 has two tuples. Okay. R1 has three tuples, R2 has two tuples, right? Cardinality. The resultant relation R1 cross R2 will have six tuples. Okay, there is a question in the exam asked in GATE, ISRO. I have put it in the slide, and they have asked if one relation has m tuples, other has n tuples, how many will be there in the Cartesian product? Turns out Cartesian product has m cross n tuples. So we'll look into that. Don't worry. So it will have six tuples. The columns will be, first you write the columns of R1, then you write the columns of R2, then you write the columns of R3, and then you write the columns of R2, and then you write the columns of R3. Now, when you try to solve the questions in the gate, people get to confuse that this, for example, this name is of R1 or R2. My suggestion is to always write them like this so that you are not confused. Okay. Now you need to do a cross product. Okay. What do I mean by that is 1 CS A C 4. Okay. So the first row I combine it with the first row. Then I combine the first row with the second row. So I write 1 CS A D5. Okay. Now I look at the second. Now I look at the second row, which is 2 EC B C4, 2 EC B D5. Okay, two tuples I have not written. Can anyone give me an example of the fifth tuple? What should be the fifth tuple? Anyone? So I combined the next one as B and this. Now I have to combine this with the third row with the first row of R2, third row with the second row of R2. So what will I get? 3CE, CC4. Perfect. So 3CE, CC4. And the last one will be 3CE, CD5. Right? This will be the six tuples that will be returned by the cross product. Okay. Now division operation is a very important operation. We'll go to that later. Okay. We'll go to that later. Don't worry. Division operation is very important. There is a question. First question is also only on division operation. So we will actually look at that when we look into the question. Okay. Now let's quickly go over the questions. These can be used for 9. Think this will be the first question. No? Okay. Okay. This was given in GATE 2017. Consider a database that has a schema. So I think it's called classroom. So CR, student name and course name are the two attributes. And they are given an instance of the schema is shown below. And the following query is made on the database. First you T1, which is this query, and then T2 is a division query. Can you all solve the T1 and let me know how many tuples you get? What are the tuples you get for T1? CA, CB, CC. Very good, very good. So what typically you do is there is a selection operation where you still select students which have name SA. So this is one, this is another, and this is another. Right? There is no other SA that I can find. Right? So your T1 will have the selection operation will give you both the columns. They are interested with only the course name column. So T1 will be course name, CA, CB, CC. Any questions? Can I proceed? All good? Understood this one? T1? Everyone? Steven, clear? Okay. 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 Now let me give you a small task. Okay. You will only answer what does division operation do. That's why. The small task that I want to give you is return me all the student names. Okay. Return all the student names which have all the three course numbers. Do you understand what I'm saying? Look at the course name. The course name could be either CA or CB or CC. Can you return me those students who have all three as a course name? Did you understand the question? Look at the student names. For example, if I look at student SA, SA has all three course names, CA, CB, CC. You can see that, right? Everyone can see that. Similarly, can you give me all those student names who have SA, CA, CB, CC as their course names? SC, SD, SF. Okay. SA will be there, right? SA will also be there, right? You guys have implicitly assumed or what? SA is also there, right? Okay. Okay. I got two answers. Anyone else who wants to answer? No? Okay. So yeah, correct. So you got some student names. Let's say the student names that you got, which have all three as the courses are SA, SC, SD, and SF. Okay. This is actually the division operation that you have applied. The division operation will return all those tuples that have all the three attributes. Sorry, what I'm trying to say here is it will return you the relation with all the student names, the name of which has all the values given in the other relation. So, for example, if I would have changed this, let's say I would have changed this CC to CD, can you tell me what would have been the answer for T2? You will have to return me those student names who have all the three values for the course name. Is there any student like that? I can see one. I can see two. I can see no more. Right? Then my change would have been SC and SD. So this is what is the division operation. Okay, so it was CC earlier, so I'll keep it as CC. And T2 is nothing but you take the course classroom, put the division operation with T1. So the number of rows returned in T2 is, what is the answer to the question? Number of rows in T2 is 4, right? 4. So 4 is the answer. Okay. Okay. Let's go to the next one. This was asked in ISRO. Very easy question. It will explain you the disadvantage of using relational algebra or the limitation of using relational algebra compared to SQL. Try this out. Tell me. Let me know what do you think, which is the answer. Right? We haven't taught you, and there is no way actually to get the sum of all the salaries. That is possible in SQL, right? But that is not actually possible if you use relational algebra. You cannot get the sum of all employee salaries. That's an easy question. Huh. Consider the join of two relations, R and S. R has m tuples, S has n tuples. Then the maximum and minimum size of the joins are what? Everyone knows join, right? I hope you know SQL, so you can also answer in terms of SQL. Everyone knows join, right? Or should I explain join? Okay. No means yes, I guess. Everyone knows. So, hmm. Rohit is saying B. So, what is join actually? Can anyone explain in terms of Cartesian product? Like, join is Cartesian product with what? So, join is if you take the Cartesian product, right? You join these two relations R and S, and along with that, what you do is you specify a join condition, which is that is the whole point about join. For example, when I explained you about Cartesian product, when I explained you about cross product, sorry, I could have said that the name of R1, right? So let me actually do that. I may say that you are joining these two relations R1, join S. So join looks like this, and the name should be the same. Okay. Typically, what you write is R1 dot name is same as R2 dot name. So the name should be the same. So what should be the result then? The result will be you will have a registration number, a branch, a name, right? You will have these three, but you will not have all the rows. Which row will you have only? Which row will you have any? Sorry, there will be also registration number here, which is from R2. So you will only have the row with name as C, right? Only the row with name as C, because that is the only row in R1 and R2 which is having the same name. Others are different, right? So it's Cartesian product with a selection, okay? Always try to keep this in mind. So you'll get registration number as 3, CE, C, and 5. Okay, 5 comes from R2 ka registration number is 5. Okay, this is about join. Okay, so what they were asking in the ISRO question was, let's say if this would have been capital E, I have the same join that I'm doing. What will be the output? How many rows will you get as part of the join output? If instead of this being C, it was capital E, how many rows would you have gotten if you would have done the join? Is there any common name between these two relations, R1 and R2? No. So you would have gotten how many rows? 0 rows. So that's a minimum number of rows that you get. And for example, if this would have been capital A, this would have been also capital A, this would have also been capital A, this would have also been capital A. What would have happened? How many rows would you have gotten if this was the case? The first row would have matched with both these rows because they have the same name. Second row would have matched with both these rows because they have the same name. Third row would have matched with both these rows because they had the same name. So the output is same as the Cartesian product. So that's why the maximum cardinality is Mn, minimum cardinality is 0. Option D is the right answer. Okay. Anyone who has any questions? Can I proceed? Okay. What would have been, let's say the relation R has m tuples and n tuples. How many will be the minimum and maximum size of union? Can you answer? Think. The attribute condition is matched. Okay, assume the attribute condition is matched, so you can actually do union. How many tuples you would get in minimum, and how many tuples will you get in maximum? Min. Okay, max is m plus n. Min. So max is m plus n. Okay, agreed. True. Min. Any guess? Hmm? And be zero. Shall I give you an example? One. No. Can I give you an example? See. Hmm. How many tuples are returned if you do union? In this example, if you do R1 union R2, how many tuples are returned? 3. Good. Let's say this was R1, this was R2. How many tuples are returned? If you do union? 3. Now can you answer? Minimum how much? Max of m comma n. Very good. Max of m comma n. Okay, is it clear everyone how it is max of m comma n? You will definitely get if R1, so it's like set theory, right? If R1 is a subset of R2, which is in this case, so you'll get all the relations of R2, right? And similarly vice versa. So that is union. How about intersection? What is the maximum number of tuples that you can get if you do intersection? What is the maximum number of tuples you get if you do intersection? Yeah, what is the minimum you will get? Minimum is easy to answer, I guess. How much will be the minimum number of tuples you get if you do intersection? Zero, right? If there is no common tuple between two relations, you'll get zero. Maximum, how much will you get? Look at this example. The example is present in front of you. Min of m comma n. Very good. Max we can get is min of m comma n. Let's say if both of them would have been the same, you would have gotten the same relation. So min of m comma n, min of 3 comma 3 is 3 only. So this is what you get. Okay. Please keep this in mind. These are, as I said, asked in the other exams, not in GATE. GATE, I don't ask that easy questions. They are asked in other exams, especially in ISRO, as you saw now. Right? So, one second. Yeah, this is, then answer is B for this. Okay. Again, another basic question. ISRO 2008. The join operation can be defined as what? I was saying this when I explained you join, so I hope you will be able to answer. Right? Capital A, sorry, option A is the right answer. That is, join is nothing but a Cartesian product followed by a selection. Please think through, try this question out. I'll give you some time. Let me know if you can. First of all, can you see the question, GATE 2022? Everyone? Because I'm seeing here ISRO 2008 for some reason. The previous question. Yes? Maybe there's some issue with my internet. Please try this out. Yes. What did you understand with the question? Again, let me tell you one small way of how to solve these questions. Look at the innermost query and try to evaluate the innermost query first, and then try to try to look at the outermost query one by one. There are some queries which are absolutely wrong, right? For example, look at option D. If you realize, what does this thing do? What does this thing do? It will try to join each employee with each brand, right? It will try to join each employee with each brand. So it will give you a new relation that is not even correct compared to the first relation. So option D may not be correct. Similarly, try to also look at option A, option B, option C, and option D. If you want me to give you a hint, what does this thing do? Anyone? What does this thing do? No, it's an MCQ. What does this thing do? Yes, anyone? What does pi of BID of own do? No, that's okay. See, that's what I know, right? It displays the BID column from own table. What do you understand? What exactly is the information that you're trying to get? Can I say it will give you the brand IDs that are owned? Is this correct? Can I say this? Everyone? Not just Vishnu, everyone? Brand IDs that are owned? Can I say this? Okay. So this is the hint. So if I have a list of all the brand IDs that are no owned, right? If I somehow try to get the employee IDs who are owning all these brands, what does it mean? How will I get that? Which operation will help me to get that? Very good. Very good. Now can you answer? Isn't option C absolutely perfect with everyone? Do you understand why option C is correct? See, what does option C do? You get all the employee IDs and the brand IDs from the table own. You try to find out all the employees who own all the brands. That is given by this. And who does actually the hard work of doing this? The division operation that will give you those employee IDs which have owned all the brands. And now you're trying to get only the employee IDs. So the correct answer is option C. What is the problem with option A? What is the problem with option A? See, option A has only one difference. The own becomes brand. When can this be wrong? When can option A be wrong? If there is a brand in the brand table that is not owned by anyone, then, for example, let's say there is a brand called B5 that is present in the brand table, but in the owned table, it is not present, saying B5 is not owned by anyone. Then this operation, division operation, will give you zero tuples. So Option C is find out the brand IDs that are owned, find out the employee IDs, check who are having all the brands, and return their employee IDs. Okay, everyone, is it clear? Yes? Okay, good. Yeah, this is not very difficult. You just have to think. So take some time. As I said, I'll give you some time for each question. Take some time and we'll come back in 2 to 3 minutes, 3 to 4 minutes, sorry. Take some time and then we'll discuss. See, let me give you a hint, okay? First, try to see what does this do. You're trying to join table employee and dependent, and the join condition is employee ID should be equal to the EID of dependent, which roughly means that you are trying to join all those, you are trying to retrieve all those employees with their dependents. And the AND will consider those employees with their dependents in case where the age of the employee is less than or equal to the age of the dependents, age of the dependent. Now you are trying to do a set difference with the employee IDs from employee. So what do you get? So the inner query is you get all the employees with their dependents where the age of the employee is less than the age of the dependent. And if you do a minus set difference of that with employee ID, what do you get? First of all, try to answer the fact that, let's say there is an employee E1, he has an age A, and the age of it is 23. Okay, let's say the dependent has a dependent ID of D1, employee ID is E1, and the dependent name is, let's say, B, and the age is 24. There is another dependent D2, employee ID is the same, let's say the name is C, the age is 21. Okay, take this table. Can you tell me what does this join, just if you do this join condition, what will be the output? Basically, what I want to ask here is, will you get even as the output or not? Understood the question? Understood the question, right? First of all, will you get even as output? What is the join result that you will get? How many of you say the answer is 5? As in, no will not zero, no tuple you will get. How many of you answer that? How many of you say the answer is not 5? See, either you are in X or you are in Y. You can't be in, either you are in true or you are in false. Answer is not 5. Okay. So that means you will get even. That's what you are saying. But there is a dependent whose age is not less than the employee's age. Then how are you getting the answer as even? I'm just trying to help you think. Okay. Why do you say it's even still? What is then giving you even? See, both of them have the same employee IDs, even and even. I agree with you, right? But the age of this is 23, the age of this is 21. Then how is 23 less than or equal to 21? What did I do wrong? Why are you still getting even? Because of D1. What does it mean then? Does it mean that all the dependents of employee even should have age less than the employee? Or does it mean that at least one of the employee of even should have age less than, or sorry, at least one of the employee should have age more than employee's age? What does it mean then? At least one. Okay. So if you are getting those employees which have dependents, at least one dependent with age less than or equal to the age of the dependent, if you exclude that part, what do you get? If at least one is not, is the answer given by the query this one, right? What does this query are? It says these are employees whose age is greater than that of. What is the negation of this? What is the negation of this? If you apply minus, it means all dependents or all of his dependents, his or her dependents. There's a difference between this option and this option. This option, if you say it's correct, it means that if an employee is there, even, and let's even A23, B1, even, B21, D2, E1, C20, D3, E2, C25. Now, will you get even as an output? Will you get even as an output in this case if you consider the whole query? What does the inner query answer in this case? What does this query answer? The right hand side. Will you get even here? No, right? See, these are the employees even. You are joining with even. But is their age less than or equal to the dependent's age? No. So you will get 5. Okay. Now you are considering all the employees in the employee table. So you have even, okay, I need to add E2 as well. Let's add E2 also because I think it's foreign key. So I have to add, let's say E2 had 24. So your this query would have returned what? It would have returned E2, right? It would have returned E2, and the first query is E1, E2, then E2. So what will you get as the answer? You get the answer as E1. So you get the employee whose age is greater than that of all dependents or all of his or her dependents. What is the answer then? Jigya, did you understand why B is not the answer? Yes, no. Should I explain again? Yes, no. Can you please repeat? See. Okay. First of all, did you guys understand that? Okay, this relation is there, right? This relation that is there. This is the employee table. This is the dependent table. Okay. Now, if you run the right hand side query, the RHS query, right? If you run this query, what is the employee ID you get? See, I will use a different color, okay? So typically you will join E1 with E1 and E1. First of all, is this fine? Everyone agree to this? Okay. Now, is the second condition true for these two tuples? Is there any dependent who has age more than that of employee? No. So will it be returned? Will this employee ID will be returned? No. Now, do you also agree that E2 will be joined with E2? Now, will you get E2 in the RHS or not? Is the answer. Is the age of the employee less than or equal to the age of the dependent? So what do you get as an output of the RHS? Will you get E2? Yes. Now LHS is very simple, right? LHS is just the employee ID from employee table. So you get the output as E1, E2. Is this clear or should I explain this? This should be clear, right? Come on, I mean, right? So if you do the set difference, that's what you're doing. Which is the employee ID you get? What do you get? E1. If you say that option B is correct, technically I can find a dependent, in this case D3, who has an age more than that of E1. Can you guys see that? So if I answer B as correct, then I am in a trouble. Do you guys understand? Because 23 is not greater than 25. But why did I get E1 as the answer? Because employee E1 has age greater than or equal to greater than all of its dependents, all of his or her dependents. So which is the correct answer now then? Option D. Okay. Again, the idea was not to teach you relational algebra. The idea was to teach you how to solve questions given a question of relational algebra. And how did I solve the question? Take an example, very small example. See, I just took a single line example, right? If you take a very simple example, you will actually get the answer. Okay, that's how I used to solve when I was student like you. It might seem it will take time, but no, it won't take much time. Also, you will make lesser mistakes because you can see the output there only, right? Okay, can I proceed, everyone? Is it okay? Very good. Okay, now try this out. Yes, first try to understand what the inner query does. You can take an example also, okay? My suggestion is take an example. Correct answer to this question is option C. C. Okay. Anyone who could answer? Okay, good to get. So the thing is, see, so this is nothing but row. The row is simple. They are just trying to rename this relation. So let's say this relation is R1 and this other relation is R2. So they are doing a self join. Right? In SQL terms, it's called self join. So there is an employee number in R1 and there is an age in R1 and they are joining it with R2, which is the same relation, but with the names of the column different. Employee number 1, age of 1, right? Now they're trying to do a join based on the condition that the age is greater than age 1. Okay. So if you have a tuple like this, let's say you have, sorry, I'll just call it employee number only. So you have employee number, right, and age. Okay. Let's say you have employee number 1, age is let's say 23, employee number 2, age is 24, employee number 3, age is 23, employee number 4, age is 25. Okay. Now you're doing a join like that, self join. So self join could be hard to visualize. Better is if I have a write it the same, right, on the beside with names as employee number 1 and even the table is the same and we're trying to do 23, 24, 23, 25. 25. And you are trying to do a join based on the condition that the age is greater than age 1. So first look at the first row of R1. So this is R1, right? And this is R2. First look at the first row of R1. There is an age of 23. Is it greater than any of the age here on R2? Is the age 23 greater than any age? Can you see any age in R2 where the age is more than, sorry, sorry. What I'm trying to say is, look at the first row of R1. Age is 23. Is there any age on R2 which is less than that, such that the condition that age is greater than age 1 will become true? Understood what I'm trying to say? I'm trying to say that, can you find an employee in R2 which has lesser age than 23? It turns out you can't, right? So there is no employee. So this tuple will not be returned. Come to this tuple. Is there any tuple in R2 which has age less than 24? There are, right? There are two actually, 1 and 3. So you may join this with this, you may join this with this. Okay. Now let's come to this tuple. Is the age 23? Is there any age on R2 which is lesser than 23? Again, there is no age, right? Now look at this row, 25. Is there any age which is less than 25? You can see there are more than one, 23, 24, 23. So what does it mean? It means the age of those employees, which is not the minimum age, will be returned. So those return the employee numbers of all the employees whose age is not the minimum. Okay. Okay. Then I go to the next question. Okay. Hmm. Yes. Try this out. My suggestion will be, um, try to always do in this way, that you write the tuples first of all, take this relation and see what is the output you get. Take this relation, see what is the output you get. You will get the answer. Okay, what are the tuples returned by this one? See, when r dot v is v2, that means what? You are only considering two rows, which is this one and this one, right? Yes? Everyone clear with this, right? R dot v is v2, so we are only considering two rows from r. Okay. Now you're joining them with capital P on y, which means the value of p dot y should be the same as r dot y. Okay. And now your r dot y can be only either y3 or y2. So which row will be returned? What will be pi of x? Can you answer now? You will join y2 with this one, right? And you will get the x of it, which is you just get x2. Is it clear, everyone? This part? Okay. Now your q dot t is greater than 2. So which rows are you looking at? You are looking at this row and this row. And you are joining them with r dot y. So which row will you join it with? Which is the common element of y between q and r? Is y1 present in r? You please don't answer yes. Even though you can see y1 is present in r, right? Okay, sorry, sorry. Yes, y1 is present. Why did I? Sorry, guys. What I wanted to say was, so okay. So actually, you will get this row and this row. Okay. So which is the x you get? What is pi of x? Sorry, I don't know why I said that. Sorry. Yeah. So you get x1, y2, v1, x1, y1, sorry, x1, y2, v3, x1, y1, v1. And you get only the x column, which is x1. Now, how many tuples will be returned? X2 minus x1. You will only get x2. So the answer is 1. Is it clear, everyone? Can I proceed? Next question. Okay. Okay. What is the next question? Takes time to load. You get. This was given in GATE 2024. This actually the last question, I guess. Yeah, this is the last question of today's class. So please take some time, try this out, and then we'll end the class. Yes, it's a very good question, right? We have asked in GATE 2024. I have given this a last question because this is actually one of the most difficult questions that they have asked of lately on relational algebra. Okay. Let me give you a hint. Mm, to actually see if there is a city, let's say C1. Okay. Let's say there is a city C1. You want to find out if three persons reside in this city C1. So how many comparisons will you do? You will maybe want to do a comparison of P1 with P2 with P3, right? For example, if I want to list the city C1, considering the fact that there is a person P1, there is a person P2, there is a person P3, all of them, all of them actually reside in city C1. So how many tables will you need that will allow you to compare P1, P2, and P3? How many tables will you need? Okay, I will give you something. Okay, I won't answer this question today. Okay, uh, please take this as a homework. I really want you guys to think through. Okay, I really want you guys to think through this question. If I tell you the answer, you will not think, right? If you think through this question and answer it, that is enough to ace relational algebra. So you can refer the internet also, right? The idea is also to get the solution if you find it from somewhere, right? Uh, but I actually took a lot of time to solve this question myself. Okay, I started like this. I wanted to have three people minimum whom I can compare that their cities are equal, right? So in that sense, I will need a table that gives me that P1 belongs to the city. I will need a table that tells me that P2 belongs to city C1. I will need a table that tells me P3 belongs to city C1, such that if I join all of them, I will get some table, some relation that is C1, where I get three people, P1.city, P2.city, P3.city as the same. And to do P1.city, P2.city, P3.city, I will need three separate tables. Okay, please think this through. Okay, I won't give you the answer today. Okay, I would really want you to go and think about this question. It was asked in GATE 2024, not very late, right? It was asked very recently. So please try to answer this question. I will discuss this question in our next class. I know it's tomorrow, but I will still give you some time. We'll discuss this question in next week. Okay, because tomorrow is the class. I assume you all will be busy learning about SQL, trying to revise your SQL concepts. So we'll discuss this question in the next week. Okay, but please take some time to think through this question. I will not be answering it today because I really want you guys to think through the solution. And if you can solve it before the next class next week, you can also, if you have any questions, feel free to ask me on WhatsApp, on the group, personal, whatever works for you, and we can resolve any doubts if you have. Okay. Do you want me to discuss any concept that you could not understand today in the next class that is tomorrow? Or relational algebra, do you feel more confident now to answer the questions? Yes? Okay. 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 So tomorrow we will be actually looking at SQL. Uh, SQL, I think, is one of the topics that you have studied. People who maybe are doing software development engineering jobs may use SQL in their day-to-day lives. I personally don't use SQL in my daily job because I don't have to work with data a lot. Compiler engineers do not work with data. That's the idea. So I do not work with data. So, but you guys work for people who are SDs. in any startup or company may use SQL on a daily-to-daily basis. So tomorrow's lecture might be a really interesting one for you guys because we'll look into a lot of things about SQL. Okay. Before I end, any questions, doubts, concerns? Yeah, 8:50 is tomorrow's class. Nothing? Okay. I will stop the recording. Again, the idea is if you guys did not understand any of the question today, the whole point of doing online lectures is you can actually go back and see the recordings. It can help you to revise. For people who are very new to all these concepts, my suggestion would be to first look at the question, try to solve it yourself, and then if you can solve, try to see how I solve it. If you can't solve, learn from me and then solve it again. Okay. So that would be the idea if I were you and someone was teaching me like this. Okay. Feel free to download the slides. If you don't have any questions, you can exit the call. Thank you for joining. We'll meet tomorrow.